opportunity to present Data Lab to you. So I'm Robert. I work at NOAO in Tucson, Arizona, and NOAO Data Lab is relatively new, I say, from last year, June, a science platform, one of these things that several groups are developing. I will show you in a second what we can do with this. Before we start, I will be attempting a demo during the poster session in the room next door. I hope that I can get the big screen, maybe a table around it. So if you're interested, bring your laptop with you. Sign up for an account. Just go to the website, datalab.noao.edu. Click on sign up. And since everybody's sleeping in Arizona so far, so I'm going to be approving those accounts when I get back to my chair. So all we ask is just for your name and email address and institution, and you get an account right away. So first, what is Data Lab? It's a community of users. It's you. And that's the reason why we exist. It was not the reason why we started, but now this is the reason why we breathe. And also it's a team of developers, scientists, database architects, engineers, system administrators, and so on. We make it work. We try to ingest data sets, enhance data sets, add some value to it, and engage with you users a lot. So you can ask us anything, and also, tell us the problems that you have, and we try to help. On the hard side of the things, it's a repository of very large data sets. They're all co-located, the catalogs and images, so you can do a joint analysis on them without having to download things from far away. We try to be good citizens, so all the services are VO compliant, I think most of them. So we have VO protocols, SQL, ADQL queries, TAP, you can use Topcat, you can query for images using the CS service, and so on. We also provide gateways to other data centers, so if there's a data set that you want, we don't have it, like VZA or something, you can just point from us, from their client libraries for that. We are, on the front end, we are a website and authenticated portal, but we also have exploratory tools where you can see what data sets look like. And importantly, we have a Python integrated Jupyter Notebook Python environment where you can do all your analysis there, so close to the data. You don't have to install anything on your computer. You can, if you wish. You can download the clients, install them on your computer as well, but then the data would have to be transferred. We do some visualization, have some visualization capabilities. All of it is Python. APIs are well documented. Hopefully, some of them is always a work in progress. I mentioned already Jupyter Notebooks. We have many common task helpers. It's a library of helpers that is growing all the time. So, from plotting histograms, libraries, arrays, scatter plots, things like that, to more complicated things like computing the period of a light curve, and so on. Also, very importantly, we offer you remote storage. So as soon as you get an account, you get a terabyte of storage for yourself, plus some hundreds of gigabytes on MyDB, so you can facilitate analysis using these capabilities. In the near future, we'll have a cross-matching service, like literally in a week or two, a first version of it, where you can upload your table of hundreds of thousands of sources, and then we do the cross-matching using Postgres database mechanisms for you. You get the result back. Also, a remote computing job manager is in the development for next year, I think, where you can then launch bigger jobs, simply submit them to the queue, and they will be computed for you. We do some machine learning, not as packages that we provide, but you can actually use all the packages that are out there. Everything is installed, and if something's not installed, just tell us, we will install it for you. And finally, we aim to be a survey data publication facility. So if you have the PI of a survey, small or big, if you want to publish it somewhere and make it accessible to other people, you can come to us, bring your own data. We give you a template for a landing page, for a description of the columns, and you can publish through us. So all these things together, what Data Lab is then is a science platform. It's a new mot du jour, or a data exploration analysis environment, or Archive 2.0, or anything you can come up with. So I started with saying why we exist. It's because we have users, but we started to develop the whole thing because we needed to facilitate some kind of exploration facility for all the 4-meter class telescope data that's been collected by NOAO telescopes at Kitt Peak National Observatory in Arizona and down in Chile. And like I said already, we want to bring the users' computing needs and your analysis to the data, not the other way around. You can do joint analysis because we ingest many other data sets. So other than the NOAO data sets, we have Allwise, Gaia, SDSS, DS, DR1, and many, many other things. And so in a nutshell, it's a science platform to prepare you, the user, for something petabyte scale like LSST is coming. And we already have a petabyte of data. So what does a user account get you? When you decide to go to a website and click on register, you see this thing on the left. We only ask for really few things. And then you get terabyte of VO storage, VO space storage, 250 GB of MyDB storage, and these are all soft quotas. So if you have a project that requires more, it's no big deal. We can give you more. You get persistent workflows also, because many things that you can do on the website or through the Jupyter environment, you can do anonymously. But as soon as you close the browser, it's gone. When you have an account, it's not gone, it's saved, and you can come back and continue later. You can also share this with your colleagues. So you can upload your own data sets, like I said, even big ones. You can create, delete, and edit notebooks. We provide a huge set of, not huge set, a big set of example notebooks, from simple ones like how to get started to more complicated ones, like how to do a science case from A to Z. So you can save all these. And of course, you can upload your own Python code. You can, anything you put in a notebook, you can save there. So some more or less current data, while I get myself some water. So on the left, you see how many rows and catalogs we have right now, and we recently closed the threshold, across the threshold of 100 billion rows. This includes all tables from catalog data to index columns and so on. And on the right, you see the data holdings in the NOAO Science Archive plus Data Lab. So it's something like 1 petabyte right now. This includes images, raw images, but also tables and calibration methods and so on. So I think like raw science, reduced science data is about 0.5 petabyte right now. So when you get to the website, you need to be able to somehow explore the data set. So one is, for instance, a AutoCAD visualization tool based on Aladdin Light. This is Gaia DR2 loaded here, but you can load many other things and then spin the globe and so on. I will show it during the demo as well. So to grow the user community takes a lot of time and a lot of effort and a lot of advertising. So here you see in blue, it's the daily rate of registrations of user accounts since we started. The first 3 spikes on the left are us, people working at Data Lab, registering on accounts, and then 50 demo accounts, and then 50 more demo accounts. And since then is a trickling registration of users. All the spikes are usually us being at some conference and presenting Data Lab, maybe like here. So there will be a spike of 20, maybe, or hopefully 20 by the end of this day. In red, you see the cumulative number of users, and green, the one if I remove all the test and demo users. So it's not like if you build it, they will come. Americans in the room maybe know the movie. It's if you build it and advertise it a lot, then they will trickle in. Okay, so when you come to us and you become a user, of course, the first thing you want to know is where do I get help? So we have a help desk with where you can ask questions, even anonymously. You don't have to, be afraid that you ask a dumb question, something that everybody will know who you are. There is already a list of frequently asked questions. Your question, by the way, will be added to that list, but if you log in anonymously or don't log in, it will be anonymous. And most importantly, humans take care of you, which I think is better than machines taking care of you. I don't have a Terminator picture here to offer. Yeah, but the point is somebody will actually take care of you, and you can ask any questions you want, from it doesn't work, it crashes, or how do I do it, or where's the data set, so on. So here is also a Data Lab user manual, which is just a Sphinx compiled document. It's never complete, it's always changing. I have to beat my colleagues into contributing to it. Most of the things are documented, including APIs, tools, things you can do with Data Lab. If something is not documented and you click on it and says coming soon, punch us to it and say, I need this documentation. There's also lots of SQL examples in there, a list of abbreviations that everybody uses. I don't understand half of them, tips and tricks and things like that. The API of the clients that we have, the clients that I mentioned you can install on your laptop if you wish to, is documented completely online. So if you need any function, if you need to explore what kind of functions are available, you can just go there and find it. Here's an example of what we have in the data. So here's something that we produce ourselves. This is led by my colleague David Neidever, who took all the public NOAO data images and re-reduced them with a one single pipeline, extracted photometry from them. So this catalog is huge now. It has like 3 billion sources, unique sources, and there's also a measurements table, unique measurements, single epoch measurements, which is 30 billion measurements. So if you are interested in time domain science, you can go there. In some fields, you have something like 1,000 epochs, so very long light curves. What else we have? The data sets that we're hosting, some of them, this is the big ones. So we have DSDR1 with 400 million objects. Decals DR3, 4, 5, 6, 7 is coming this month, I think, and 8 will be coming next year. DECAP, somebody mentioned yesterday, is in there. the NOAO source catalog I just showed, Gaia DR1 and 2, of course, FAT for Andromeda, which is also a dark energy camera, All-Wise, SMASH, SDSS 13 and 14, and we have also a testing field, a Stripe 82 field with all of those and others already pre-cross-matched for you. Many of those tables or databases have already pre-cross-matched tables. Very simple, 2 arcsecond cross-match as the nearest neighbor. So this is very fast if you wanted to do that. I alluded already to it. There's some temporal information in some of them, like in the NSC, a lot of epoch. SMASH has several epochs there. And I think LSDR8 next year will have all the temporal information there as well. In the future, like I said, DR7 is being loaded right now. We are also loading right now LSST simulated catalogs. Will be available later this year. Then the big thing, the next big thing for us is the DESI spectra. So far we only have photometry, but this will be a spectral thing. So we're developing a spectral viewer and analysis tool for that. And then some skinny versions of Polsterers and LSST. Skinny being, we have to decide which columns we ingest, not 1,500 columns. They are available in Polsterers, for instance. More of LSSD and, SDSS. And then I'm looking personally to include some X-ray catalogs, which we don't have right now, but for people doing AGN science, for instance, this is super important. And potentially your data, if you're interested in adding that to the pool, just talk to us. So there's a short list of the current functionality that we have in Data Lab. So you can authenticate, you can become a user and get an account through the web, through the Data Lab command line tool, a dedicated Python client, or you can do things anonymously. Sky exploration tool, like I showed you already, and also a catalog overlay on that tool as well. We have several ways of querying the catalogs through the website for exploration, but the most convenient one is actually in the Jupyter Notebook using the query client, which I will demonstrate in the demo. We also have a dedicated Data Lab client, which you can download and do this whole things on your computer. And of course, we are VO compliant, so you can use TopCat, for instance. We support simulated image access for cutouts of images for most of the surveys. Some of them don't have image data published, but those who have. You can get the query results directly to your notebook environment or store it to MyDB, your personal database, or store it, for instance, in a CSV file to the VO space. File transfer, several methods for that. Visualization, like I said already. Analysis happens in Jupyter Notebook. And like I said, common task, there are tools, for instance. When you query a database, the return string is a CSV formatted table. So you can automatically stream it through this helper and then convert it to a pandas data frame or NumPy array or whatever you want. A few words on visualization. Everything that is in Python is actually installed. So Matplotlib, VEX, IPyVolume works, Bokeh, we're exploring currently, including Glue, and maybe a Firefly next year, which is the one used by LSST, and the spectral visualization tool and so on. So if there's anything missing that you would like to have that you use, just let us know. We will try to get it installed. And so before finishing, a reminder about the demo. Come and sign up and try it. You can contact us through email, website. We are on GitHub if you want our code, on Twitter as well. And you see on the left, on the right-hand side, your right-hand side, is we have a state-of-the-art Data Lab call center. I'm just kidding, so people hacking together during one of our tutorials. Yeah, give us a call or shoot us an email. Thank you very much.